Welcome to MicroAI's Training on the Edge with MicroAI AtomML. This video will demonstrate how MicroAI embedded on a robot controller can detect 5 separate abnormal events, and how this is related to operational excellence, predictive maintenance, and security attacks. We will utilize a Dobot Magician robotic arm that is small enough to fit on an office desk, controlled by a robotic controller, and is similar to many industrial welding and handling robots that are set to do a task during a defined shift. 2 sensors will be used to collect data to send to the MCU via a hardwire I/O. One sensor is placed at the base of the robot to measure changes in motor temperature. Another sensor is placed on the arm joint to measure movement pattern changes, and the controller measures cycle time and arm joint values and sends data to the MCU via a local network message store protocol. The microcontroller unit supports free RTOS and can handle MicroAI AtomML's small footprint. All sensor and controller data is fed to the microcontroller unit, which feeds the channel's data to MicroAI, which generates the predictive output that is sent to the Helio Cloud dashboards via MQTT protocol using the MCU Wi-Fi module. MicroAI can also be deployed in environments with more advanced processors, such as NPU-based Linux devices, Windows laptops, and Blade servers with an x86 or AMD 64 CPU architectures. To begin training the robot, here we see it operating as normal. MicroAI is initiated in training mode to measure the sensor and controller data from the robotic arm to create the machine learning model. We set the training for 300 seconds and ingestion frequency for each channel at 1 second. Within 300 seconds, the AI engine can catch the normal cycles of robotic arm behavior to build a robust AI model. Sampling at a 1-second frequency, the data points for humidity temperature and acceleration are ingested at a sufficient resolution to identify behavioral patterns and anomalies. While in training mode, the AI engine collects the data at the endpoint, where the user has an ability to clean and conduct feature engineering on the data. When training is completed, the model file is built and housed on the MCU, ready for use. The AI engine is run in execution mode while the robotic arm is in operation. MicroAI can now generate inference outputs such as alerts, health score, days to maintenance, and more using the train mode based on the statistics of detected abnormality to derive these numbers, and will continuously learn and predict from the live data coming in from the attached sensors. To demonstrate a behavior change in the robotic arm, we push the button and the Dobot changes the x-axis. We can see the change in the X sensor, and a notification arrives to let us know that there was a significant change in behavior than our model expected. By demonstrating a single tap in the robotic arm, for a single hit to test out a small collision, we can see the change in health score, X sensor, and a notification arrives to let us know that there was a change in behavior from our model expected. With multiple hits, the dashboard sees significant drops in the health score and further out of bounds appearance in the sensors. By demonstrating a full obstruction in the robotic arm, the dashboard highlights the health score, drops in the predictive days to maintenance, an alert appears, and you can see your sensor readings that indicate the change. Now we review the security dashboard for new information, monitoring data traffic, and providing a behavior matrix. While we run a simulated distributed denial of service attack on the Dobot, we see the health score change as traffic monitors and an alert appears, showing abnormal Dobot behavior through the appearance of colored blocks. The security dashboard can catch zero-day attacks as they initiate, giving you a head start to stop and help your systems. MicroAI prevents the breakdown of any asset or equipment. Learn how to predict and circumvent equipment failures by embedding intelligence with MicroAI AtomML. Visit www.micro.ai today.